Hello friends, in this video I'd like to solve the following problem from the International Mathematical Olympiad 1986, problem number 5, which was proposed by the United Kingdom. We wish to find all functions f from the set of non-negative numbers into itself, satisfying the following three conditions. First, f of x, f of y times f of y equals f of x plus y for all non-negative numbers x and y. Second, f of x is non-zero for x's between 0 and 2, 0 inclusive, 2 exclusive, and f of 2 is 0. So it's a nice problem, a bit unusual, but very classic problem, I'd say. Here are my hints. First, change x to x minus 2 and set y to be 2 to find f of x for x greater than or equal to. And for every other number, set x to be 2 minus y for y between 0 and 2, and show that this inequality is true, f of y greater than or equal to 2 over 2 minus y. Then, suppose that at that point you should guess that in fact there should be equality, and we will have our formula. And to do that, suppose that inequality is strict for some y0, and show that it leads to some kind of contradiction. For example, you may wish to write that f of y0 is 2 over 2 minus y0 times 1 plus epsilon for some positive epsilon, and try to get some contradiction. And finally, do not forget to verify the result you get to make the solution full. So give this problem a try, and I will see you in just a minute. Right, so as I suggested, let's start with setting or changing. So change x to x minus 2 and set y to be 2 in our condition, in our equation number 1. And also we need to assume that that x is greater than or equal to. So then we have the following. Our equation becomes f of x minus 2 f of y times f of y, but y is 2 really, so we can put 2, equals f of x minus 2 plus 2 f of x. Right, and now let's take a look. What is f of 2? Well, f of 2 is 0 by condition number 3. Which means obviously that for every x greater than or equal to, our function is constantly 0. Let's call this condition asterisk. Alright, now let's set something else. Now let's set y be, or x to be 2 minus y in our condition, in our equation number 1, where let's assume that where y is between 0 and 2. Then our equation becomes the following. F of x, but x is 2 minus y, times y, f of y rather, sorry, times f of y equals, well, on the right hand side we have f of x plus y, but f of x plus y is just f of 2. Now, notice that this expression f of y is non-zero by condition number 2. By condition number 2, f of x is non-zero for arguments between 0 and 2, and I assume that y is between 0 and 2 by condition number 2, while the right hand side is 0 by condition number 3, which means that this expression equals 0. So f of this equals 0. Alright, and now I will use condition 2 once again. So by condition 2, condition 2 says that if argument of our function is less than 2, the value is not 0. So it means that the argument of our function is greater than or equal to, which after division means that for every y between 0 and 1, 0 and 2, f of y is greater than or equal to 2 over 2 minus y. And I will mark this condition double asterisk. Now, I wish to show that in fact this inequality is equality. So now, to do that, I will suppose to the contrary that we have strict inequality for some number y. So suppose now that f of y0 is strictly greater than 2 over 2 minus y0 for some y0 between 0 and 2. That means that we can write f of y0 equals 2 over 2 minus y0 times some number greater than 1, and every number greater than 1 can be written as 1 plus epsilon for some positive number epsilon. Alright, and now, crucially, let's set x to be 2 minus y0 over 1 plus epsilon, once again in our equation number 1. Notice that then we have the following. On the left hand side, we have f of x times f of y, and also let's set, maybe I will write it that I set also y to be y0. Times f of y0 equals f of x plus y. F of x plus y. Alright, and now let's take a look. This entire argument written in yellow, if you multiply this equation, it is just 2 by the definition of by this condition. So maybe I will mark it triple asterisk by condition triple asterisk. It's 2. So the entire left hand side vanishes. It's just 0. It's just 0 because we have f of 2 is 0 by condition, maybe in different color. It's 0 by our equation number 3. While on the right hand side, we can, maybe let's write it. On the right hand side, we have, after simplification, we will have 2 plus epsilon y0 over 1 plus epsilon. Alright. But now, by condition number 2, once again, yes, condition number 2 says, let's go back. Condition number 2 says that f of x is non-zero for arguments between 0 and 2. So by condition number 2, we know that our argument must be greater than or equal. Our argument must be greater than or equal 2. And that means in turn that this is true. And finally, y0 is greater than or equal to, which is a contradiction because we supposed that our number y0 is strictly less than 2. Contrary to the fact that y0 is less than 2. Which means that this supposition that our inequality is strict does not hold. So we have established that for every y between 0 and 2, f of y equals 2 over 2 minus y. And let's mark this condition, I don't know, square. So now I will combine this equation with the previous fact, which I marked single asterisk, that for every x greater than or equal to, f of x is 0. So combining single asterisk and square, so combining single asterisk and square, we have the following. The only possible solution is given by the formula. It's 2 over 2 minus x for x between 0 and 2, and it's 0 for x greater than or equal to. Right, but now we have to do verification. Very important. Verification will be partitioned into separate cases. Verification. So remember that we have to verify our very first condition. In essence, we have to verify 3 conditions. First condition, or rather, let's go backwards. Condition number 3, is f of 2 equals 0? It is satisfied. It is satisfied, no problem there. Condition number 2, is f of x not 0 for x's between 0 and 2? Well, clearly it is satisfied. No problem there. And finally, the only problematic condition which requires some work is condition number 1. And now we have to do some work. I will consider separate cases. Case number 1. Case number 1. Case number 1. Y is greater than or equal to. Well, notice that then f of x times f of y times f of y, well, what is it? Well, this part vanishes. It's 0, so it's 0. On the left-hand side, we have 0. And on the right-hand side, we also have 0. Well, why is that? Because the argument of this function is greater than or equal to. And for arguments greater than or equal to, our function is 0. So there is no problem there. Case number 2. Let's consider case number 2, where y is between 0 and 2. Notice the following. Before going on, I will show the following. Note the following equivalent inequalities. Well, then, maybe let's write it then. For sure, f of y is 2 over 2 minus y, and I claim the following. We have the following inequalities. X times f of y is greater than or equal to, it's equivalent to saying that 2x over 2 minus y is greater than or equal to, and after multiplication, it's equivalent to saying that 2x is greater than or equal 4 minus 2y, which is equivalent to saying that x plus y is greater than or equal to. So we have 2 subcases now. Or maybe let's write it, let's call it case 2.1, when x times f of y is greater than or equal to. Well, then on the left hand side we have f of x, f of y times f of y, and that disappears. It's f of 0, it's just 0, sorry, 0, because we know that this argument is greater than or equal to. But also notice that 0 is also f of x plus y, because by our chain of equivalences, this is also greater than or equal to. So no problem there. And the last case, the last possible case, case 2.2, when x times f of y is less than 2, then we have the following. On the left hand side, we have f of x, f of y times f of y. Well, since this is less than 2 and y is less than 2, we can write it's 2 over 2 minus x f of y, 2 over 2 minus y, and let's write it, it's 2 over 2 minus 2x over 2 minus 1 times 2 over 2 minus 1, and after simplification, it's what exactly? It's 2 over, well, we will have, maybe let's do it slowly. It's 2 minus y over 2 minus y minus x times 2 over 2 minus y, which is 2 over 2 minus x minus y. And let's write the right hand side, f of x plus y. Well, f of x plus y, well, it's exactly the same. It's exactly the same as we know that our argument is less than 2. And this is less than 2, and this was less than 2. So in every case, our condition number 1 is satisfied, conditions 2 and 3 are satisfied as well. So in fact, we know that our function is indeed the only solution. So the only solution is this function f written in green ellipses. And that is it. So thank you very much for watching. I hope that you've learned something new this time, that you've enjoyed my video, and I will see you next time. Goodbye.